Um, Guys, I have given this lecture note in the Canvas, so you can download it and take a look. So here it's mostly discussed some of the basic things of the MC wall, and at the same time, it's in these lecture notes we also covered like the steel strips, the design of the MC wall with the steel strip reinforcement. So basically, what we need to find out is when we have the metallic strip reinforcement, we need to find out how the thick the reinforcement has to be. So it's kind of like that. So it has a thickness, and so when we need to go to determine the thickness, first of all, we need to know how much area is gonna cover, because it provides the tensile force or the pull-out force. So first of all, it has to be sufficiently thick so that it can take the amount of loading it's supposed to take. At the same time, we have to add some factors for the corrosions. So right here, our total capacity, the actual thickness of the reinforcement that needs to be used in the construction, which is the final size of the reinforcement. So the final size of the reinforcement has to be the T design, which is depending on how much pull-out resistance it's gonna have, and at the same time it has the R. R is the lifespan of the structure, R multiplied by the lifespan of the structure. So it's the rate of corrosion. So within the rate of corrosion, another thickness is being added, and eventually the total thickness of the reinforcement will be calculated. Now, uh, there are some general considerations that to design a MSE wall. So one of the primary consideration is it has to satisfy the internal stability of the system, as well as it has to satisfy the external stability of the system. So let's cover the external stability of the system, and then we'll go to the internal stability of the system. So the first one is the sliding, and which is extremely same as the retaining wall problem. So I'm just gonna give you some overview, but I may go a little bit faster because we already know this idea. So the first one is the sliding. The sliding happens like at the base of the MSE wall. So right here, whatever the frictional force is there, that's gonna resist any kind of movement of the wall. But the design for the MSE wall is completely designed by a consulting firm and is being built by a company. Usually there is not very much a design build option, but if there is the design build option, the contractor will do it in a different way. Anyway, so what happens here is within the MSE wall, it has the reinforcement, and that reinforcement is not creating an interlocking. That's one thing, and or maybe it's creating the interlocking, but the sliding capacity of at the base of the wall is not that good. So considering that, it might have some sliding resistance. So to to check the factor of safety against sliding, we need to calculate how much weight of the wall is there and all other numbers. And based on that, we need to calculate if the amount of lateral pressure is good enough to resist the wall in place. The second one is the overturning moment, or the factor of safety check for overturning. Overturning means if the wall is too slender. If the wall is too slender, in that case, with a small push, it's gonna tilt, right? So, for example, it's our wall and there's a push, it will tilt. And if it's gonna tilt, it's gonna not gonna retain the same amount of load. And if it's not gonna retain the same amount of load, you'll have some impact, you know. Anyway, so that's overturning. So for the overturning, we need to know how much load is working out of the load. Most likely the load will be at the middle. So out of the load, we need to calculate the momentum, and then we need to calculate what is the weight is trying to cover by itself, and then we just need to do the math. The third one is the bearing capacity. Bearing capacity failure means it's a foundation failure. So bearing capacity failure, what happens in the bearing capacity is it doesn't have all the accessories that is needed. So In the bearing capacity failure, what happens is it's kind of gonna move. The foundation is weak and it will have some kind of slip surface at the bottom. So that's the bearing capacity failure, and has to be designed for the is very similar to the foundation designed for bearing capacity. And the last one is the deep seated stability. There is nothing connection with the internal stability of the problem, but and if you see the wall, the size of the wall is within limit, but here we are sitting at the retained backfill. And if there is a global stability consideration, then retaining wall itself is not going to work, but at the same time has to add some other additional reinforcement. So that's pretty much it for the external stability. We'll do a problem, and we will gonna cover it in our next class.